Hello again. Tonight we're going to talk about radio telescopes in Argentina. And the reason why that come up this week is something that we'll get to towards the end of the presentation, but you'll realize it. So science is something that is international. It's an aspect of human curiosity. All nations on the planet that can afford to do so do some kind of scientific or educational or research. If they can get other nations or educational institutions or research institutions to help them with the funding for creating facilities or deploying them or maintaining or enhancing them or operating them, as well as if that nation doesn't have the science people to do it, then maybe they'll also have that other country provide science and technology staff that are just there to assist. These agreements exist between allies as well as between, amongst adversaries. So the US has its, Europe has its, the EU, UK has its, China and Russia have theirs. And so these sorts of agreements exist all over the planet. And they use these instruments for a variety of things, mostly for the progression of the human aspect of science. So any reports or data typically appear in periodicals that are internationally readable or in papers that are published internationally. And these facilities are multi-use. They might be shared for other things like private, commercial, or military purposes for either those local governments or for other members of their agreement parties. We do this in the US with our astronomical sites, and we do this in other countries. The Vera C. Rubin Observatory in South America, NASA's not the prime funder for it. The U.S. National Science Foundation, in conjunction with the U.S. Department of Energy, actually was the provider of the funding and operational resources to get it functional. And whether you know it or not, the DOE manages the U.S. nuclear arsenal. So that doesn't, provide you confirmation that Rubin is a U.S. military facility. It's just that's the piece of the puzzle that said, we can use it to do other things. So if you ever seen little poofs or arcs going across the sky, please let the DOE know. Otherwise, feel free to use it for astronomy. So they were meaningfully providing resources to get it online and operational. So NASA could kind of quietly pull out the funding. So why do you need radio telescopes in Argentina? Well, the Earth is a globe. There's this thing called the equator that divides the northern hemisphere from the southern hemisphere. What you see in the sky at night is divided by the northern hemisphere and the southern hemisphere. So if you're in the northern hemisphere, you don't get to see the whole sky at night. You don't get to see what's in the southern hemisphere. You have to put observing facilities in the southern hemisphere. And that includes places like countries in South America, countries in Africa, or Australia. If you notice from your high school geography, South America dips well below where Africa and Australia do. And that little hook down at the bottom is actually Patagonia, which is part of Australia, part of Argentina. And so that's why there's an interest to put observatories in Argentina, as well as Africa and Australia. But they also use those locations for satellite ground stations. The financially dominant nations tend to be in the northern hemisphere. It's just history. That's the way it panned out. But that means that the southern hemisphere nations kind of get divided up by kind of the east and west dominant nations in the northern hemisphere when they want to observe from the southern hemisphere. So you may see that we do a lot of work in Peru and Chile with west-leaning observatories in countries, and that kind of leaves it, for the other countries, if you want to have a place in South America, you wind up in Argentina. Or there are some shared sites in Peru and Chile, Bolivia, places like that. I found it surprising that U.S. universities, big name universities, actually have invested in astronomical science, radio and optical in Argentina. And both Yale and Columbia universities have made investments down there. With all the other countries kind of locked in, that left China, which is a U.S. adversary, to invest in Argentina. So you've probably heard of the U.S. NASA Deep Space Network. This is the 3 observatories we have spread around the globe at 120-degree offsets that allow us to communicate with space probes out in space. Now, these are not Earth orbiting ones. These are the ones that are farther out, like James Webb Space Telescope, Lunar Reconnaissance Orbiter, the Lunar Flashlight, Mars Reconnaissance Orbiter, both the Curiosity and Perseverance rovers on Mars, the Europa Clipper on its way to Europa, Psyche, the one that's going to look for metal asteroids, JUICE, Jupiter's Icy Moons Observer, New Horizons, and Voyager 1, 2 out at the far edge of our solar system. So to do that, you need a big ear, you need a big dish, and you need at least 3 of them separated by 120 degrees so that you can, regardless of which way the Earth is pointing, get a signal out that far and then get data back. Getting the signal out that far doesn't really require that big a dish. Collecting enough radio photons to make sense of the signal when you have something that's 5+ billion miles away, you need a big dish to collect up all those RF photons. You need that sort of thing. There are other nations on the planet that have done deep space science, including China and Russia, with missions to the moon, Venus, and Mars. Surprisingly enough, China has their own equivalent of the Deep Space Network. It's called the Chinese Deep Space Network, or CDSN. China's northern hemisphere, but it's a very wide nation. So they actually have these sorts of radio stations in the north, southeast, and west of China to cover as much as they can. But that leaves out a lot of the southern hemisphere. So they've invested in large antenna observatories for radio in Argentina because they were willing to, hey, you want to leave some space in our country? You want to build your big ear at your cost, operate it at your cost? Can we use it occasionally? Can we, use it for our purposes when you're not using it for yours? Sure. That's why you get these sizable astronomical facilities in Argentina that are funded by China. We are probably aware of the GPS, the Global Positioning System, but that's what the US calls it. The generic term for it is Global Navigational Satellite System, or GNSS. And you can buy a receiver that will receive from these internationally agreed frequencies. And you buy a GNSS receiver, and it can also receive GPS. But the US, the UK, the European Union, Russia, and China each have their own GNSS networks, satellites, ground stations, as well as on-the-ground high-precision time and clock sources. These are not geostationary satellites. These satellites are zooming overhead. They're what is known as median Earth orbit, or halfway out, higher up than low Earth orbit. So they stay up there longer. They last longer. They might be up there for 10+ years instead of 5. Typically, the technology will become old hat, and the capacity will not be what is expected, and the accuracy of the onboard clock will not be as expected, and they'll get replaced more often due to technology improvements than other things. But the secondary thing is they have large solar panels to provide their electricity, and because they're in higher orbit, they're more exposed to solar radiation. So the panels don't last as long. Because they're higher up, they tend to not need as much fuel for keeping themselves in their orbits, but eventually they're going to run out of their fixed supply of orbital correction propulsion fluid. So they have to be replaced occasionally. And all nations that are owning of a GNSS do this sort of thing. And the ground stations, you need multiple ground stations because the satellites are zooming overhead. And if you need to talk to a satellite that is not currently overhead for where your ground station is, you have to wait until the satellite goes overhead. But given that it's medium altitude orbit, you've got fairly wide. It can be sort of nationwide ground station coverage. So you need ground stations in a number of nations around the globe, and each one of them needs a hydrogen maser for its communication synchronization and atomic clock synchronization. The U.S. has a number of these in both the U.S. and other countries. China has also numerous ground stations in China because it's a big, wide country, but they also need them in South America. So in Bolivia, they have 2 ground stations. In Brazil, there's a ground station. In Chile, there's a ground station. In Venezuela and in Argentina. And the one that gets the most attention is Tierra del Fuego, towards the very southernmost tip of Argentina. Because if you want to put a ground station in any further into Tierra del Fuego, it needs to be in Antarctica. And for radio astronomy purposes, if you have a big dish, 100 meters across or whatever, that's not as big as you can go. You can use software and technology algorithms to make a collection of radio telescopes look like a radio telescope that is the diameter of the largest separation of the outermost observatories. So if you see down at the bottom, you can create an Earth-sized, very long baseline interferometer that goes from Spain, sort of across the U.S. to South America and over to Australia. So you can create a single synthetic aperture radio telescope that is that big. But in order to do that, you're going to need something in South America. Now, that's for sort of U.S. or U.S. and partner synthetic aperture radio telescope observing. But let's say you couldn't put one in North America, couldn't put one in Spain. What would you do? You'd need to sort of rotate the world underneath it, put some in China, put some in Africa, put some in South America, and now you can create a large interferometer. And so Felix Aguilar's complex in San Juan province in Argentina has the abilities and the time sources and synchronization sources for doing interferometry. But the dish at that location is only 59 inches across, which kind of limits the sensitivity. So adding a much larger radio astronomy antenna would improve scientific research, both for that site and as an interferometer. And enter the project known as CART. This is the China-Argentina Radio Telescope, CART. And it is 131 feet across, 40 meters. It looks kind of like one of our big ears, our big Deep Space Network antenna parabolic dishes. And you see it sitting on the ground here. They fabricated the primary parabolic antenna, and they're now building the base. And they've got a bunch of secondary stuff to put on the inside of the dish. And then electronics, they've got a control room they're building. This is probably on the order of $1 billion or $1 billion plus that China is footing the bill for in order to establish this massive radio antenna in South America for scientific research. Now, if you think, well, China, scientific research, radio astronomy, there is something called FAST, the 500 aperture, I forget what the other letters are, space, I think it's Astronomical Space Telescope. Given that Arecibo is now no more, this is the largest single radio astronomy dish on the planet, and it's for scientific purposes in China. So they have the skills to make one of these things come into being from nothing. And in about 1 to 2 years from now, they plan on beginning operational testing of it, if they're allowed to complete it. As it turns out, the U.S. recently invested billions of dollars in Argentina, and it's not clear how much of that money is going to be spent funding scientific research programs. It's my understanding that the work on the CART Radio Astronomy Observatory has been suspended, and it's unclear as to whether, if or when, it might actually resume. If that gets discontinued, the CART antenna itself is the property of the government of China until it gets turned over to Argentina. It's unclear whether the U.S. could complete the work, but it's obvious from the funding I've read so far that the U.S. has no intention on providing a similar size radio astronomy observatory. We have the capability. I mean, we built Arecibo. We improved the Deep Space Network just prior to launching James Webb Space Telescope. But I read over the funding for the fiscal year 2025 and 2026 for things like NASA, and there's nothing in there to build a large radio antenna in Argentina. This is a significant setback for astronomical scientific research for the nation of Argentina. Yes, CART can be used as a Deep Space Network station, regardless of whether those probes are used for scientific or other purposes. even if it's used for the Deep Space Network, it'd be useful for advancing space exploration, whether it's for crewed missions or not. Once you get out towards the moon, it'd be nice to be able to communicate with your astronauts on board your spacecraft, regardless of what nation. And the US doesn't allow unfriendly nations to use the NASA Deep Space Network that JPL operates. A dish this size is meant for collecting very weak signals, and it literally talks to only one thing at a time. If you're trying to listen in or communicate with things in Earth orbit, this is an excessively large antenna. You could use multiple smaller ground station antennas to communicate with with far more than one satellite at a time and listen in on lots of things. And as I already indicated, there's lots of ground stations in South America already. Given the diameter, CART is more likely to be purposed for studying weak celestial signals like pulsars, which has been indicated as the reason why they're building it. It can only point in line of sight, so it's needed for looking at deep space probes. Let's say China wants to send a space probe out to, I don't know, Jupiter. If it doesn't have a dish this big in South America, they can't execute that science. So not only does China lose out, Argentina loses out as well. Historically, the US has always developed better and more capable things in space in order to progress space exploration and scientific research, including the creation of the Deep Space Network itself. So we've surpassed other nations' efforts by doing bigger and better. This is the first time I've ever seen it where our investments have, whether directly or indirectly, hindered scientific advancement by other nations, but that's just my point of view. So in summary, scientific curiosity. It's international. It's an aspect of human nature. Not all scientific research takes place in the US, some amongst allies, some amongst adversaries, nations, universities, and research institutions, in order to progress things that they can't otherwise take on independently on their own, either because of funding, don't have the engineering folks to do it, or don't have the scientific folks to operate it. They're going to establish agreements with allies and adversaries. These sorts of big instrument projects can have multiple uses. They can do scientific research. They can do military investigations, as has been seen with the Rubin telescope in South America, or they can do commercial satellite communications. Knowing who the partners are in an agreement is no assurance of the exclusive intended purpose of something. If the U.S. chooses to reduce scientific funding within the U.S., cut NASA's budget, that impact is not confined to the U.S. because other nations rely upon the U.S. to do scientific research. Lose by two nations or multiple nations. If the U.S. chooses to reduce funding internationally, contributing to other nations, that impacts those other nations, but also affects things worldwide, including our adversary. If the U.S. shapes international alliances by investing in what they want to invest in and then derailing other international scientific research efforts, that impacts scientific progress across the planet, the U.S., its allies, as well as its adversaries. Remember that some of the passengers that are aboard the International Space Station are Russian cosmonauts. Adversarial relationships do not mean science is not pursued in a collective manner. Just saying. And then for those people that don't know of these things of which I speak, links. Now, I didn't cover all of the astronomical radio and optical instruments in Argentina, let alone around the world. You can go to Wikipedia, and they have a list of all major observatories, regardless of sensor type, around the world, and the observatories themselves can contribute to that list. So when a new one gets turned up or taken down, they can adjust the list. So how many people knew that this sort of struggle for observing existed across nations?
Didn't know, but not surprised.
Yeah. I was a bit surprised that the U.S. would use its financial might to basically derail scientific research of other countries. Do I put it past them? No, but that was usually the efforts by US agencies, CIA, NSA, those kinds of things. But for it to be done at just an overall governmental level out in the public, that's different. But steer clear of the politics. Comments, questions on the topic? Okay, then it'll be a short one and I'll stop recording.